Children, today in this practical session, I will tell what we have learned in our theory parts. I will show you that. Okay. First, as I told last class, this is known as a resistor. Okay. And as I told the color coding, first we can see the color coding. Okay. Look here. In this part, this is the shown. This is a resistance. Okay. Here it represents 1 kilo ohm. 1 kilo ohm means 1,000 ohm. Kilo means 1,000. Okay, we can see that when we change this value, look, I changed it to 1 ohm. Correspondingly, we can see that this color code, these bands are also, color of the bands are also changing. Okay, now let me give 1,000 ohm. I would say 1,000 ohm. Okay. Yes. 1,000 ohm. It is, as I told firstly, that is this 1,000 ohm is similar to that of 1 kilo ohm. So that we can see that is similar to that. Here it become red value. Okay. Now let me change this value. Okay. Here we can see that these are the different configurations. You can see that means this is ohm. Ohm is a unit of resistance. That is here it is kilo ohm, mega ohm, and like that there is also small ohm measurements such as milli ohm, etc. Okay. Now we can say take one. I'll show 1,000 milli ohm. 1,000 milli ohm. We can see that according to our color coding diagram, its value, this color coding also changes. Okay. Now let me check 10 milliohm. Okay. Let me check that. Okay. 10 milliohm also, here also this color is changing. Okay. Now we can take mega ohm. Yeah. Look here. Here it become blue. So according to that color coding digits, when we change the digit, this color codes also changing. Okay. I hope that this is, you understood. Now let me say what is resistor in series and parallel. Okay. I am taking another resistor. Okay. When we place these two resistor like this, okay, then we will provide, just for example, we are providing across a voltage. I am placing it. Okay. Okay. Escape. One second. I will take the battery first. Okay. I am taking this maybe, yeah, 9-volt battery I am taking. Okay. I am placing it here. Okay. Okay. Now I am drawing a wire. Okay. Here it is. Yeah. I connected to the negative. Here it is. Okay. Then connecting this terminal 1 to this positive. Let me check what is happening. I'm giving start simulation. Okay. Since we have not given any say any LED and all, we cannot see whether the current is passing or not. As I told in the slides, that is when two resistors are connected in series. This is on a series connection. When they are connected in series, the total resistance will be sum of individual resistance. Sum of this resistance plus sum of this resistance. Okay, that you need to remember. Okay, now let me show you parallel connection. Okay, I am removing this wire. Okay, and I am also removing this wire. Okay. Now, okay. Now I am taking this here. Okay. Now we are placing these two parallelly. Okay. I am connecting from this end. I am connecting it to here. Okay. And similarly, I am placing from here to here. Okay. This is known as parallel connection of resistors. Here I am showing only case of two resistors. It can be parallel resistor, can be 3, 4, or any numbers. That means here the resistance, this is the equivalent resistance will be, we can continue to the battery. I'm not showing it again. Okay. Here the equivalent resistance will be this 1 by equivalent resistance. That means 1 by total resistance is equal to 1 by this resistance of this resistor's value plus 1 by this resistor's value. But in case of series connection, that is sum of resistors. Here it will be reciprocal and sum. Okay, I got you. I thought that you understand this. Okay, now let me remove this all. Now let us do a basic exercise. Okay, in last class I have shown you how to connect using a breadboard. Okay, let me change the orientation of the battery. By clicking here, we can change the orientation. Yeah, I am keeping it straight. Okay. Now let me bring the breadboard small. Okay, I am placing it here. I'll give a small recap. That is, in breadboard, this you can see that this first in this side, every these dots you can see here, right? Yeah, these dots will have if we connect a negative of the battery to any one of the points here, this total line will be having negative charge. Okay, when we connect the positive of the battery to the this any one point of this dotted lines, then we can take the positive from any one of these points. So for example, if we connect the positive to this point, we can take the positive from for any other component from any point in this line. Okay, that is the purpose of this. Okay, but in this part we can see that here the connection is in the like a vertical, so that here the wire is connected vertically. This this 28th line will have no connection with the 27th line. This is the basic concept of a breadboard. Okay, this you need to know while doing a connections. Okay, now let me take this. Okay, I am connecting the positive. 1 second. Yeah, I am connecting this positive from here to the positive of this thing. Yeah, I have connected this. I'll make it properly. Okay, from the positive here, and from here I am connecting to the positive. Here it is shown that which is positive here, and no confusion will occur. As I told last class, we can change this color to red, so that there will be no misunderstanding. Okay, then this negative part I am connecting here. Once again, let me change the color. Okay, to black. Okay, yeah, now it has become black. Okay, I place it here, and to the negative part. Okay, you can place this negative anywhere in this line. Okay, then there is no issues. Okay, now we need to connect our say led and a resistor. Okay, for that purpose I am taking a led here. Okay, I am taking this led. This led I am rotating it, right? First I am placing it here, then I am rotating it. Yeah, 1 2 3. Yeah, now I have rotated this. Look here, this is anode and this is cathode. This is negative, this is positive. Now let me place it here or somewhere here. That's that according to our wish we can do it. Okay, but another point you need to remember. uh, okay, if we can connect like this, but as I told, only this line have connection. We need to connect it to this line. I'll show you that thing. Okay, 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 1 second, I'll place it here for okay understanding. Okay, now this leg is cathode, that is negative, so that we have to take the negative from there. Okay, for example, yeah, I will show that this is a negative. As I told, this is negative. I'm drawing a wire from this negative part to here. Yeah, now this negative part will come to our cathode. Okay, now this positive part we can place a resistor. Okay, I am placing a resistor, yeah, here. So why we are placing it like that? Because here we can see, as I told, this connection will only happen in a straight line, like in this case. Okay, so I place here. If I place this resistor somewhere here, this connection will not go to the anode. For that case, you need to remember, always place it in the straightly. Okay, now I have placed here like that. Okay, now now let me do start simulation. Okay, yeah, look here, our led is glowing. When I give stop simulation, our led is off. Okay, now for this much we have done last class. Okay, now to know to measure the current or voltage, we can use I'll show you a multimeter. There is a device known as multimeter. You can search here. we got it, multimeter. This is a multimeter. Yeah, I am placing it somewhere here. Okay, I am placing it here. Okay, then I will show you what is the purpose of this multimeter. This multimeter can measure voltage, resistance, or we can say or current. Okay, I will show you that. In this dialog box we can change this. If you want to measure the current, we can change it to amperage, so that this multimeter can measure the current. When we change this amperage to voltage, it will measure voltage. To when we change it to resistance, it will change the resistance. Okay, like that. Now we are going to measure the current. Okay, here we can see that this is negative. In this negative part we have to connect to the negative part itself. Okay, I have connected negative to negative. Okay, and this positive part, right, I am connecting it to any lead of the this positive. Okay, I have connected that. Okay, now when I am doing this chart simulation, yeah, we can see here the what means this is the 6 ampere is, it shows the amount of current passing through this circuit. Like this we can what we can say, we can change this value. Okay, we can change it to voltage, so that 8.99 volt is the amount of voltage we are supplying. That means it's a 9-volt battery. This 9-volt battery will supply 8.99 volt, that is approximately 9 volt. Okay, now here we can see I will show resistance. Yeah, this show error because we in this case we are not directly connecting to any resistance, so that it is showing error. Okay, so we can use a multimeter to measure current and voltage. Okay, I hope it is clear. Today's class, I hope it is clear. You need to work out this on Tinkercad. It's a free website. You need to go to Google. Just click on the Tinkercad and you need to log in with your email ID. And after that, you should click on the circuits, Tinkercad circuits. And there are many simple examples given. You can just go through that. And after that, you should do it on your own in your mobile phones or laptops or computers. I hope you understand this. Okay, thank you.